Hi everyone. In this video, I am going to explain you how to calculate the ABD matrices of a composite laminate using ANSYS Workbench. So basically, the ABD matrices is nothing but A is extensional stiffness matrix, and B is coupling stiffness matrix, and D is bending stiffness matrix. So these are the formula we can use to calculate the component of the ABD matrix. So in this video, I have considered one laminate which is having 0 degree, 30 degree and minus 45 degree ply orientation, and these are the material properties, and each lamina is having 5 mm thickness. So open the ANSYS Workbench, open the ACP pre. So basically first we need to define the material property. So for that we have to select the engineering data. So go to engineering data source. So I have already defined the composite material. So here graphite epoxy is our material. So select it, and here the structural steel is not required, so disable it. Then close the engineering data. Then we have to create one geometry. So I'm going to use the design modeler geometry. Select XY plane. So based on your requirement, you can set the scale level. So here I'm going to consider one rectangular beam. So select the rectangle, create rectangular cross section, define the dimension. So the length of the beam is 0.1 meter and the width of the beam is 0.02 meter. Okay, so by using this figure, I am going to create one surface body. So go to concept, select the surface from sketch, then you can select the sketch, then you can define the thickness. Just press generate. So you can able to see here surface body. Okay, by using this surface body, we are going to evaluate the ABD matrix. So next we need to use the model. So the model is used to convert the CAD geometry into the FEM model. See, if you look at there under the geometry, you can able to see question mark. It means we supposed to define the material for our surface body. So select the graphite epoxy. Now you can able to see the question mark is disappear. So use the generate mesh. So by default, I'm going to use the mesh size. So here you can able to see the FEM model. So right click and update it. Next step, to evaluate the ABD matrix, we have to go to setup. So edit the setup. Okay, so here you can able to see the update. So once you are going to update, you can able to see the thickness as 0. If you want to look at your material data, you can look at through materials. Then fabrics. So fabric is nothing but which is used to create or which is used to assign the material and the thickness of our lamina. Okay, so here the thickness is 0.005 meter. You apply, you okay. Then stack up. Okay, stack up is used to create our laminate. Okay, so here first lamina, second lamina, and third lamina. So first lamina is 0 degree, second lamina is 30 degree, and third lamina is minus 45 degree. Okay, next go to analysis. If you want to look at this property, you can look at, or otherwise you can directly select the laminate stiffness and compliance matrix. You apply, you can able to see one new window. So in the new window, you can able to see the stiffness matrix and the compliance matrix of our defined laminate. So this is the combined ABD matrix of our defined laminate, which is having 0 degree, 30 degree and minus 45 degree. So this is the stiffness matrix. Okay. So if you look at there, this is the A matrix, B matrix and D matrix obtained by using the equation. So this is the stiffness matrix obtained directly from the ANSYS Workbench. Okay, so this is the combined matrix. In the bottom, I showed you the A matrix, B matrix and D matrix separately. So in this slide, so here this is nothing but comparison between the analytical formulation and the ANSYS Workbench. So both the matrix, okay, so both the way, I mean the ANSYS Workbench and the analytical formula, both the matrices are closer to each other. So by this way, we can compare our FEA formulation through the analytical formula at the initial stage. Okay, so this is the one of the way. So this is the reference book I followed. Thank you.